All right. Hello, everyone, and welcome. This is my 7.1 video. Again, this is going to be a more difficult style problem, but 7.1 is covering integration by parts, right? So this is an integration by parts problem. And in fact, if you remember, right, this hyperbolic sine, hyperbolic cosine, right, these are really like these e functions, right? The exponential functions. Since here is e to the x minus e to the negative x all divided by 2. And so you can kind of think of this as similar to sine of x times e to the x. And we know that these are going to be these sorts of problems that wrap around on themselves. So that's what we're going to see here with this problem. But again, if you're trying to apply your Lyot or ILATE, this kind of trick for remembering, what should be u, what should be dv, then you can, think of this as an exponential, right? The hyperbolic sines, hyperbolic cosines are really exponentials there. Okay, so with that out of the way, why don't we get to it? I'm going to try to integrate this, and well, I already spoiled, right? Integration by parts is going to be the technique. So I'm going to go ahead and let u be equal to sine. After all, trig function there. And dv, kind of thinking of this as an exponential, right? The hyperbolic sine. Let's go ahead and calculate out these other pieces. Should include a dx there. And when I integrate hyperbolic sine, we get positive hyperbolic cosine. Okay, and so now I'm going to do a rewrite here that our integral is going to be equal to uv, so sine x hyperbolic cosine x, minus the integral of v du. So v du. Okay, and now we can see again with these ones, it's kind of surprising, right, that doing integration by parts one more time does actually, help, because this doesn't look all that much simpler at all, right? It seems like just as difficult as what we started with. And so you really have to know for these types of problems that you need to do integration by parts twice and just kind of, remember that it's going to work out here. So I'm going to kind of pull off to the side here and do this separate problem right here. I'm going to try to evaluate out hyperbolic cosine of x times cosine of x dx. Evaluate this integral. And similar as before, right, we're going to use a integration by parts method here. So I'm going to let u be equal to cosine of x. Du then I can calculate out is going to be negative sine x. dv is going to be the other stuff. So mainly the hyperbolic cosine. And then v is going to be positive hyperbolic sine. And so, okay, we can go ahead and apply our integration by parts formula. And this is going to give us uv. So u cosine of x, v hyperbolic sine of x, minus the integral of v du. So v and du is going to be negative sine. So that negative I'm going to bring out here. And this is what I was talking about, where it kind of wraps around on itself. So we can see that here was our original integral, and we can see that after 2 iterations of integration by parts, we get that same quantity again showing up. But let me go ahead, right? We need to kind of carefully plug this in. So I'm going to cheat using technology a little bit here. I'm going to copy, paste. And we just evaluated out this bit here. And we found it was all this sort of stuff, right? So this integral of hyperbolic cosine times regular cosine was all this. And notice one of the most common mistakes that I see is really forgetting to distribute this negative sign right here. And so that's why I included these parentheses. I think these are incredibly important. Just making sure that, you don't drop that negative sign. It needs to be subtracting away this entire quantity, right? This entire integral here. And so now that we've rewritten this and it has multiple parts, right? Again, we need to subtract away all of it. So let's go ahead and distribute that. So I'm going to go like this. And now I've distributed my negative sign. So now we have the same quantity here as we do here. So I'm going to add on this quantity to both sides, right? Add on this integral of hyperbolic sine onto the right and onto the left. And so when I'm thinking about this, right, I'm really thinking that, this is just some quantity. I don't know exactly what it is, right? It's some A, and we've added on another A, right? And so whenever you have A plus A, it's just, well, 2A. So it's just 2 times whatever that quantity is. And so that's really what we're doing here, is that whatever this quantity is, right, we add it to itself. Now we have 2 of them. On the right-hand side, of course, these cancel out very nicely, and we're left with sine of x hyperbolic cosine of x minus cosine of x hyperbolic sine of x. And so the last step, if you want to solve for what is this integral equal to, right, we can just divide by 2. And I guess really at some point here, I should be kind of carrying around this plus c. I'm just going to include it right here. So now let's go ahead and divide by 2 on both sides. I'm regretting not copying and pasting right now in my head. So yeah, I'm going to divide that by 2. And we have plus this constant. And you may notice, right, you say, why don't you divide that c by 2, right? Well, it's a constant, right? We don't know what it is. But technically it has changed, but it's still just a constant, right? So if before it was, 5 or something like this, now it would be 2.5. But again, we didn't know what it was either way. And so it's still just plus some constant. And so that's why we just leave it as plus c. So this right here is going to be our final answer. And of course, if you had some extra time and if you were paranoid about this being correct or not, right, you could take the derivative of this. And if you take the derivative, right, you should get back to this function right here, sine x hyperbolic sine x. And that's exactly what an antiderivative is, right? Something that if you take the derivative of it, you get back to where you started. All right. Thanks a lot for watching, guys. I hope you have a wonderful week, and I'll see you out there.